This is lesson 3, sample spaces, and a cool down called sample space of sample space. What this lesson is all about is trying to really figure out what does your sample space look like. So probability represents the proportion of the time an event will occur when repeating an experiment many, many times. For complex experiments, the sample space can get very large very quickly, so it's helpful to have some methods for keeping track of the outcomes in the sample space. In some cases, it makes sense to list all the outcomes in the sample space. So, for example, if you flip 3 coins, the 8 outcomes in the sample space are heads, 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 tails, heads, tails, heads, tails, head, 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 tail, tail, tail. Okay, it's a lot. And it might be kind of hard to figure out, wait, am I actually getting all possible outcomes? Am I really representing everything that could be in my sample space? This is a fairly simple one, but even this is a little bit complicated. So there's a couple different ways that we can visually represent sample spaces when we're doing probability. First way is you can use a chart like this. Now, I don't necessarily recommend a chart like this because it seems to be a lot of work. It's a little bit confusing. If this makes sense to you, great. Go ahead and do that. My preferred method is to draw a tree structure. And what you're doing is you're going to think about what's going to happen for each of the 3 coins separately. Instead of just tossing all 3 of them into the air, what happens if you flip them one at a time? Both of those scenarios, you end up with the exact same sample space, but by thinking of it as independent events one at a time for each of those 3 coins, we can draw a tree. So for our first roll, or our first flip, sorry, thinking number cubes again. For our first flip, we could get heads or tails. And then for the second flip, if we got heads on the first, we could get heads or tails for the second one. Or after the first flip, if we got tails, we could have also gotten heads or tails for our second flip. And then our third flip, well, if we flipped a heads first and then heads again, the third coin could also be heads or tails. So if you look at this, we have heads, heads, heads as one option. We have heads, heads, tails as another option. We have heads, tails, head, head, tails, 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 head, head, tails, head, tails, 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 head, tails, tails, tails. So we have 1, 2, 3, 4, 5, 6, 7, 8 possible pathways across our little branching tree here, which means we have 8 different possibilities for our sample space. Now, that's assuming that the order actually matters, because if you take a look at this, if you flip all the coins at the same time, a tails and 2 heads, a tails and 2 heads. It's kind of interesting. Anyway, the potential possible outcomes is, you can see those all there. Now, one letter is chosen at random from the word sample, then a letter is chosen at random from the word space. Write all of the outcomes in the sample space of this chance experiment. What are all the possible outcomes? Well, if your first draw, you get an S from sample, you have 1, 2, 3, 4, 5 different letters that it could go with. So how many outcomes are in the sample space? If the chart idea makes sense to you, go for it. Otherwise, draw a tree diagram of your sample space and then see if you can figure out what the probability that the letters you chose are A and A. How many possible outcomes in your sample space are an A and an A, divided by how many possible outcomes are there total. If you have any questions, let me know.